Happy Monday, Algebra 1. We are continuing on with our lessons on inequalities and linear inequalities. But real quick, I want to give you a quick refresher on what we're talking about to remind you after this wonderful weekend. So you guys have spent a lot of time with just straight lines, graphing lines. And here I have the line graphed y equals 1/2 x plus 3. So over here I've got my y-intercept of 3. And then I went up 1 over 2, up 1 over 2, up 1 over 2. And that is my line. Anything on that line is a solution. However, if I change this equal sign into a greater than sign, well, sure enough, I don't just have solutions that are on the line. I have solutions that are above. This is greater than. So if I have just a greater than sign, I am shaded above the line. If I change that to a less than sign, I am shaded below. Those are where all of my solutions are. Let's flip this up to a greater than, and if I add an equal sign here, well, currently I have a dashed line here. I currently have a dashed line. If I add an equal sign, well, that dashed line turns solid. So if I have greater than or equal to, I am solid, shaded above. Less than or equal to, I am solid and I'm shaded below. So remember, greater than, dashed above, less than, dashed below. Greater than and equal, solid above, less than or equal to, solid or below. So this is what we did last Thursday and Friday. Now, you guys ended class on Friday. Some of you guys came down to my classroom and asked about this. But we had this toy problem, and I want to go over this toy problem together real quick because that is going to lead into our lesson today. So here's what we've got with the toy problem. It says, a small toy company specializes in toy cars and toy trucks. However, the company is limited in how many cars and trucks it can make in a day. And here are its constraints. Each car needs 4 wheels, each truck needs 6 wheels, but there are only 360 wheels in stock. Seats. Each car needs 2 seats, each truck needs 1 seat, there are only 100 seats in stock. So we're going to be writing 2 inequalities, one that is discussing our wheels and the other one that is discussing our seats. So let's go ahead and write out 2 equations for this. We're going to write out 2 equations for this. All right, so first off, we have x is going to be our number of cars, and y is going to equal our number of trucks. And we're going to be writing out 2 inequalities that represents what we've got going on here. We've got something going on with our wheels and another thing going on with our seats. So let's go ahead and talk about wheels first. Our wheels. Well, just like we did our money problem, wheels. Our cars need 4 wheels, so we have 4x. Our trucks need 6 wheels, so we have 6y. And we only have 360 wheels to go with. So we're going to have a less than or equal to sign with 360. So we have 4x plus 6y has to be less than or equal to 360. So that is our situation with our wheels. Now let's talk about our seats. Our seats, we're going to have a separate issue. Seats. Our cars need 2 seats. Our wheels, or our trucks, only need 1. So you can add a 1y, or you could just say 1 there. It doesn't, or just y there. But we're currently I have 2x plus 1y, and I have 100 seats in stock. So this needs to be less than or equal to 100. So here are our 2 equations, our inequalities, shall I say. For our wheels, 4x plus 6y has to be less than or equal to 360. And for our seats, 2x plus 1y has to be less than or equal to 100. All right, now, if I judged properly based off of what you guys were saying when you came down and asked me questions about this one, we were struggling with graphing this. Now, one option that you could do is solve for y, and it should be a fairly simple equation, but I'm actually going to graph this in a different manner. So I know this is probably not going to be as straight and nice as yours is. 10, 20, 30, 40, 50, 60, 70, 80, 100, and 1, 2, 6, 7, 8, 9, 10. All right, it's not perfectly spaced, but it'll have to do. All right, so looking at this, if I wanted to graph this first inequality, I have 4x plus 6y is less than or equal to 360. Well, let's say that instead of worrying about cars or trucks, let's say I only worry about cars. Now, if I say, you know what, we're not going to make any trucks here. We're just going to make cars. Well, if I say 0 is y, I'm left with this inequality. 4x is less than or equal to 360. And if I divide both sides by 4, well, 360 divided by 4 is 90. So the maximum number of cars I could make if I just made cars is 90. So I'm going to go ahead and put an x-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go ahead and put an x-intercept right there at 90. And I'm going to do the same thing for y. If I say, well, let's forget about cars. Let's only make trucks. Well, I'm left with this inequality. 6y is less than or equal to 360. So if I divide both sides by 6, then I could have 60 total trucks. So 10, 20, 30, 40, 50, 60, 60 total trucks. And since this has an equal sign there, this will be a solid line. So go ahead and make a nice solid line there. And since we are less than, well, let's think about it. Could I make more vehicles or less vehicles than that? Well, that would be less than. So that is our first inequality. So real quick, let's go ahead and graph the second inequality. And we're going to have one area that we are going to have a solution. So same thing. Let's say that I only wanted to make cars. Well, 2x is less than or equal to 100. If I divide both sides by 2, this could be up to 50. 1, 2, 3, 4, 5, 50 right there. All right. Same thing with trucks. If I were to say, hey, let's say that we're not making any cars. 1y is less than or equal to 100. Well, that would be a y-intercept of 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. We have an equal sign, so this will be a solid line. And then a less than, which means we could make less vehicles than that. So let's see how straight of a line I can do. And we are shaded below. All right, so real quick, I want to talk about what each of these areas mean. And Mr. Parsons is going to pause the video here in a moment. But we have 4 different areas. We have this area up here. We've got this area right here, this area right here, and finally this area right here. All different areas going on with different shadings. Now, I'm going to go ahead and label the first area. This area out here, there are not enough wheels. And there are also not enough seats. So this area, not enough wheels, not enough seats. And we've got 3 other areas. 1, 2, 3. I'll call this area 2, this area 3, and this area 4. So Mr. Parsons is going to pause the video here, and what I would like for you guys to determine is, what do each of those areas represent? Not enough what? We've got enough of this, but not enough of this. So Mr. Parsons, go ahead and pause the videos, and I would like for you guys to determine what do those 4 or those other 3 areas represent. And go. Hey, here is what I came up with. Go ahead and check your answers. So first one, area 1, there were not enough wheels, not enough seats. Area number 2, well, we are in the green, so there were enough seats here, but there were not enough wheels. We were outside of that wheel zone. So there were enough seats here, but not enough wheels. Over here, this is the exact opposite. We've got enough wheels, but we don't have enough seats. And finally, area number 4, this is what we are looking for. This is where we've got enough seats and we've got enough wheels. So anything that is in this region is a solution. And to help us out, I went ahead and graphed this on Desmos as well. And a little bit straighter and cleaner than what my drawing was. But you can see those 4 regions. Not enough of anything over here. Enough seats, not enough wheels. Enough wheels, not enough seats. And anything in this region is going to be a solution. So if we wanted to, we could make 20 cars and 40 trucks. That is a solution. 10 cars and 50 trucks, that would be a solution. However, if we were to have 40 cars and 30 trucks, well, that is not going to do. We've got enough wheels there, but not enough seats. So this is what we are looking at here. We are looking for regions where it is shaded in both colors. Let's go ahead and look at our notes for today and try to find where are we shaded in both directions. All right, so I'm going to actually start you guys off with a nice easy one. What I would like for you to do is Mr. Parsons is going to pause the video, and what I would like for you guys to try to do is go ahead and graph example 1. I'd like for you to graph example 1 and see what region is our solution going to be in. So Mr. Parsons, go ahead and pause the video. Make sure, students, we're paying very close attention to which one of these is dashed, which one is solid, and I want you to show me where is the solution area. All right, Mr. Parsons, go ahead and pause the video. All right, I'm going to go ahead and show you these answers one at a time. So first off, your first equation, or your first inequality, you had y is greater than x plus 2. Well, you should have had a y-intercept of 2, up 1 over 1, up 1 over 1, and we are dashed and shaded above, so this should be your first region. For your second inequality, you had y is less than or equal to negative 2x minus 1. So here's what this one should look like. So first off, you have a y-intercept of negative 1. Your slope is down 2 over 1, down 2 over 1. And since we are less than, we are shaded below. So our intersection, what should have been highlighted in both colors, is this one all the way over here. So some possible solutions to this. Negative 4, 2 would be a solution. However, let's look here. I want to be very, very careful. So to show you negative 4, 1, that is definitely a solution. However, if I were to change this to negative 3, negative 1, well, I know it's very tempting to say that this is a solution because it's very close. However, because this is dashed, this would not be considered a solution. That is not shaded in. This would not be a solution. Let's throw out another one. Let's say I've got the point. Let's go with negative 3, 5. So real quick, think about this to yourself. Decide, would this be a solution or would this not be a solution? Give you 2 more seconds. And sure enough, this is a solution. This is shaded in both colors, and since this is a solid line, this would be a solution. All right, so Mr. Parsons is going to go ahead and pause the video here in a moment. What I would like for you guys to do is example number 2. So go ahead and try to do example number 2. And one thing that I do want you to be careful of with example number 2 is this very, very first inequality. So currently here's what we have. We have x minus y is greater than 4. And I'm a little nervous that we're going to graph that incorrectly. So if I want to solve for y, I'm going to go ahead and subtract x from both sides. And look at this. Negative y is greater than negative x plus 4. Now when I divide by a negative 1, here is what my new inequality is. Well, a negative divided by a negative is a positive. However, because I divided by a negative, this inequality sign changes. So this is now a less than sign. And then a negative divided by a negative is now a positive. This is x. And then finally, 4 divided by negative 1 is minus 4. So this is what that very first inequality is going to look like here. So here's our system now. X minus y is greater than 4 turns into y is less than x minus 4. And the second we need to graph is x is greater than or equal to 1. So Mr. Parsons, go ahead and pause the video, and they need to go ahead and try example number 2. All right, here were my solutions to this one. First off, y is less than x minus 4. I've got that nice dashed line and shaded below. X is greater than or equal to 1. That is a solid line, and I want all x's that are bigger than 1, so I'm shaded to the right. So my final region that is shaded in both colors is in my bottom right. So here's what I would like for you guys to do for practice tonight. We've got 2 things that we need to kind of work on here. First off, we are going to be talking about this bagel donut question. So if you would like to, just try to write the inequalities for this. So just try 3a. And then for your actual graphing ones, what I'd like for you guys to do is on page 153, Just do numbers 1, 2, 3, and 4. And that's it. Have a good day.